Okay, Asma, let's have a little look from where we left off today. But there's that picture we had of the 14 Bravais lattices. So these show the different 14 types of unit cell. So all crystal systems, when you look at their unit cells, fall into one of these 14 categories. There are a couple of exceptions, but leaving aside those, these are the 14 categories. The easiest one to talk about is the simple cubic one, which is at the bottom here. That's where all the angles are at 90 degrees and the length of all the axes equal each other. Hence it says A, because they're all of the same, each axis has the same dimension. What it means by a unit cell is that if you take this one, and if you wanted to build up a big structure of your crystal, all you need to do is to take this unit cell, put it next to an identical unit cell, next to an identical one, next to an identical, and do this in all 3 dimensions, and you'll end up with a massive crystal lattice. So that's all you need to do. So the unit cell is the simplest unit if all you're needing to do is to put it next to each other, next to each other in whatever dimension you want. Okay, so that's the simplest one, but it works the same for all the other unit cells. So take for example a triclinic one, then again you can put the unit cell next to each other and build up a big structure. In your system for hydrocerussite, it so happens that depending on how you look at your unit cell, you could say that it has a rhombohedral or it has a hexagonal unit cell. So there's 2 different ways of describing it, and sometimes it's better to describe it as a rhombohedral one, and sometimes it's more useful to describe it as hexagonal. But they belong to the same system. The hexagonal unit cell actually it looks like a cube, but it isn't. Okay, and that's because if you look carefully, it's got that angle of 60 degrees. In actual fact, it's part of a cube. And so let's have a look. Let's compare rhombohedral and hexagonal in your hydrocerussite system. So we've got this one here. This one is the hexagonal unit cell with the it's hexagonal, but it's got hexagonal unit cell. And there it is. There's 60-degree angle here, and there is the unit cell. Okay, you can turn that round, and can you see there's those nice layers of carbonate groups? And this is hydrocerussite. The OHs form layers in between the layers of carbonates. How about if we represent it as a rhombohedral unit cell? Well, let's have a look. We'll bring the rhombohedral one over. This is the same structure, it's hydrocerussite, but this time represented with a rhombohedral unit cell. So it's the same structure, it's just got a different unit cell bolted described by a different unit cell. So if I was discussing this, I would probably show the 2 pictures with the 2 unit cells and just say there are 2 different unit cells for describing this. So let's have a look at cerussite then. So I'm going to input the data. So to do that, what I've gone and done is I've gone and typed in, I've gone to Google, I've looked at the rough site, RRUFF, and typed in cerussite. And it's got down here diffraction data, and then I've looked at the diffraction data. So this comes from a reference, so you'd need to reference this, and the reference is just above. And within that unit cell, it's placed the lead, the carbon, and the oxygen in these places. So the other thing it says that it's got its space group. So if I go back up to the top here, somewhere it's got the space group as well. Sorry, I missed it there. The space group is PMCN. Alright, and you can see the lattice dimensions. So the A, the B axis, the C, and these are the angles between them. So I'm just going to place those into the table. Of course, I forgot to show it on the screen. So here it is, cerussite again. Here's the, I went into RRUFF, looked at the space group, which is this one here, PMCN. These are the lattice positions of the atoms, or some of the atoms within the unit cell, and you've got the lattice dimensions A, B, and C, and these are the angles. So I'm going to now place them into Vesta, and to do that, take that back over there. I'll go to Edit, so File, New Structure, and then on the structure parameters, unit cell, sorry, first, I'll put in the unit cell first. So the unit cell says, once again, it said unit cell was PM and PM. See, right, with cerussite, when we looked at the rough site, it says that the space group was PMNA. So PNMA is actually orthorhombic. So if we look back at Bravo unit cells, actually if we look back at the rough itself, which is here, you can see that MCN, sorry, is the space group. Can you see it's 90, 90, 90? So in other words, this is when you get 90, 90, 90, it's an orthorhombic unit cell, and you can see A, B's and C's, they have different lengths, so it's orthorhombic. So if we go back to the other picture, anyway, it's this one is actually PNCM is part of the PMNA space group, which is orthorhombic. So for cerussite, you need to get number 53, then you click PNCM. So we're now going to fill in the cell parameters. So along the A-axis, these ones, this one, when I look across, is 0.25 angstroms. This one is 0.417 angstroms. Been talking nonsense because that seems a very short unit cell. So let's go back and have a look. The actual unit cell is 5.1824. The B-axis from cerussite is 8.4957, and the C-axis is 0.24560. The others are greyed out because it's orthorhombic, and therefore everything else is 90. Okay, then we go on to the structure parameters. Let's check that's still there. No, that's something's wrong here with the C. 6.1440. It's the end of a Friday. So say OK, edit structure, edit data. Right, so let's go back to there. That's all our data we need. Then we want structure parameters. So we want new one, and the atom we want is, we change the atom. So we're going to do lead first of all. So if I just move over here, you can see there the structure parameters we need to put in. Those were the unit cells. So structure parameters are now going to put in. So we're going to find a symbol PB. So the symbol is lead, and we're going to do X. I think I'll just copy and paste if that works. Y. Z. Occupancy is 1. The value for B is 0.858. Okay. Okay, new. So that one's the lead one on the top. Then we've got carbon, so we're going to change the symbol to carbon. And I'll fill the rest of the table in. Right, okay, I've filled in all the data for lead, carbon, and the two oxygens which are in different positions, and I'm going to apply. Say OK. Now this is my unit cell, my orthorhombic unit cell with the atoms inside. If I go over here I'd like to change my carbons. Usually carbons are done black, so I'm going to change it to black. There we go. Okay, right, so now I've got oxygens in red, carbons in black. And now I'm going to add some bonds. So for the bonds, I'm going to specify a new, and then I'm going to say I want them between carbon and oxygen, which I've just done. I'll delete this line off. Carbon and oxygen. Okay, and I say okay. Now I can see my carbon and oxygen bonds, and you can say that cerussite also has a layered structure. It just doesn't have the hydroxide ions in. Right, something wasn't wrong with this. It looks like there's too many carbonates and they're very close to each other. So I've just had a look, and it's not actually, it's PNMA is the right one, and then this was MCN, so I got that quite wrong. So if I apply that, say OK, right, now that looks a lot better. Right, so in other words, let's go back to the, let's check that again. Edit data, structure parameters, unit cell, it is PNMA. So if I go back to my Word document, it's 62 PNMA, which is the same as PMCN, and PMCN is the same as what's on here, PMCN. So in other words, it's number 62 is what you want. So number 62, that's fine. So now this is my structure of cerussite. So the layered structure is a little bit different this time. Now there are some things you can do here. You can represent this as a ball and stick, but you can also do a space fill model. So there's your space fill model of cerussite. You can find some other ones, wireframe, stick. Generally don't use those. Space fill one's a good one, but ball and stick shows it best really. Right, so from there, I think we can see how we can represent the cerussite and hydrocerussite unit cells, showing some of their crystallography.